All right, cool. I'm going to get started here. Thank you all for coming to this session, and hopefully you'll stick around here in the track for the next couple talks. My name's Chris Munns. I'm here from Amazon Web Services, and I'm going to be talking today about serverless chatbots with Amazon Lex and AWS Lambda. This is my first time ever at a GOTO conference. So far, pretty awesome day. A lot of really good, deep talks. Whoops, one too far. But I really appreciate you providing me some feedback on this. And let me know what I could do better in the future if I were to come to these conferences or just in general. So in terms of who I am, again, my name is Chris Munns. I'm currently a senior developer advocate for serverless at AWS, based in our New York City office. I've been at AWS for just about 5 years now across 3 different roles. Previous to this, I was the global business development manager for all our DevOps products. For a little over 3 years, I was a solutions architect at AWS. But I actually come from an ops background. So I'm someone who spent time in data centers doing rack and stack and wiring and managing Linux hosts and doing a lot of shell scripting and all that kind of stuff. And over the last couple of years, I've kind of focused more on the DevOps space, so doing a lot of CI and CD, infrastructure automation. And then kind of over the last 12 months, I've become really excited about what serverless is. And what's funny is my interest in serverless pretty much throws my entire previous career experience out the window. So a little bit of a challenge, but I think one of the really interesting things in the industry, and we'll be talking about this more today. So why are we here? So 2 different topics today kind of married together. One, chatbots, the other, serverless. We'll start with kind of a brief intro to how we think about serverless at AWS. So when we talk about serverless, we talk about services that kind of meet 4 different criteria. They have to not have anything for you to manage or provision, so no instances, no physical servers, obviously, not even containers. So we don't consider containers anything that has to do with serverless. They will scale with usage. So what this means is that you should never have to say that you need a certain amount of widgets or gizmos or instances or anything else in terms of throughput or capacity. Going along with this, you should never have to pay for idle. So if you're never going to have to pre-provision things, then you should never have to pay for idle things that are sitting around being unused. And then lastly, we believe that high availability and fault tolerance should be built into it. So at AWS, we have a concept of regions. These are these geographic locations where we have our infrastructure. There's about 16 of those today around the globe. Those are then made up of availability zones. You can think of them kind of as independent data centers that are typically within a couple miles of each other, such that we typically recommend that customers build their infrastructure spanning availability zones for high availability and fault tolerance. But in the world of serverless, you should never have to think about that planning of where your infrastructure lives. It should be completely taken care of and provided for you. Another aspect of serverless, and it kind of goes back to the keynote this morning, is this concept of event-driven computing. And so we've seen event-driven computing really take off in the last couple of years. And then what that's led itself to is this concept called functions as a service, by where you completely decompose your application down into individual functions. And those functions are ideally only being executed at event trigger time and providing the value that they do based on what that function does. And so in our model at AWS, we find the center of that world to be a product of ours called AWS Lambda. And I'll come back to talk about Lambda a little more depth towards the end of this session here today. So we consider Lambda to be serverless in the sense that it's event-driven, it's function as a service, and it meets the 4 prior criteria that I was talking about. So you never have to pre-provision it, you never have to deal with scaling it, you don't pay for idle, and it has high availability and fault tolerance built into it. And again, we'll talk about Lambda and see it in action here a little bit. Now, Lambda is a pretty hot service for us. We launched it back in 2014. And what we've seen is customers doing all sorts of cool things with it. So there's a number of different use cases, from web backends to web actual applications, chatbots, IT automation, Amazon Alexa. So the Alexa is powered by Lambda for its skills largely. And then things like data processing, which is actually a really huge use case for Lambda. And so today's talk, obviously, we're going to be focusing on the chatbot use case for Lambda and what it can do to help simplify the backend that you have for your chatbot. So enough about Lambda. Let's come back to the next topic, which is that of chatbots. So we've seen over the last, I guess, just about 10 years now since the iPhone came out, this huge evolution in terms of how we are dealing with interfacing with computer-based applications. So once upon a time, we had punch cards and then tape-based applications. Eventually, we moved on to GUI-based applications, pointers, sliders, things that we clicked on and did stuff with. And now what we're finding is that there's a lot of applications that are conversational based. And so companies are making use of chatbots for all sorts of different things, whether they be customer support related or sales related or information related. You've got things like Pizza Hut, which has an app that you can use to order pizza. Capital One, which has a capability through Amazon Alexa to check out your bank account status and other banking information. All sorts of different companies that are using it for support reasons. I know I've used it once to process a return from an e-commerce company that I bought something from. And so this new generation of interfaces is very different. And so there's some key characteristics that make up this new world of interfaces. Again, the other ones that you had were very rigid, punch cards being incredibly rigid, then moving on to things like web interfaces where you had certain key buttons, certain things that you could fill in. But now when we talk about chatbots, we're finding is it's a completely different way of communicating, right? Chatbots can kind of have a personality to them. And we see this again with things like Alexa, with Siri, that they have kind of a personality that they're known for. Sometimes you can ask them things, funny things, tell me a joke or something like that, and they'll respond back and do that. And so we see them being much more natural in terms of the way that you communicate with them, ideally much more accessible, right? So whether you have, you speak a different language, or you have maybe a certain dialect to a language, or you live in the South and you talk someplace, or you live in Chicago and you talk really, really weird compared to those of us from New York City, right? There's all these different things that we want our chatbots, whether text or verbal based, to work for. On demand, so we don't necessarily know when a chatbot might be used. It's a lot more unpredictable when it comes to average customer load or usage for a chatbot. And then lastly, we want these to be very efficient, right? We want to give people the information that they're looking for very quickly. And they may not necessarily know what they're looking for, but we could do things to guide them in the right direction. So I already kind of talked about some of the use cases, and there's just a lot that are out there, broken down across kind of 4 main categories that we see. So informational bots, again, things like you land on a website and it says, hey, do you have any questions about what you're seeing here? Application-based bots, so this is what I kind of like to lump together into what people today call chat ops. So chat ops is this new kind of IT movement / functionality focused thing where teams are building bots to help them with things like deployments, monitoring, metrics, all sorts of infrastructure related things. Enterprise productivity bots, so we're seeing companies now building bots internally to help with things like processing insurance claims, let's say. There's a number of different things that are out there. And then Internet of Things bots, and these are typically ones that you don't interface with exactly the same way as these others, but this is things like asking Alexa to turn on the lights, or asking Alexa to lower the blinds, right? These are kind of different ways of interfacing with not a computer interface that's going to give you all their information, but with the world around us in a somewhat physical way. So given all this, though, there's a lot of challenges typically with bots. For years, people have been making bots, and typically you have a very pre-programmed interface. You're expecting some preset text to be put in, or certain phrases. And as you try to get more and more dynamic of those phrases, it requires a lot of interesting technology to support that, right? Not all of us is going to go into an app like the Domino's Pizza app and order pizza the same way. Some people might say, hey, I want a pie. Hey, I want a pizza. I'd like a pepperoni pizza. There's all sorts of different things that one could say that would cause the bot, we would hope, to be able to understand what we're looking for and be able to act upon that. Then again, we've got things like language differences. So a whole number of different kind of things that we'd be looking into that are issues or challenges with traditionally writing chatbots. So at Amazon, we've been working on this problem, and we launched the Alexa a couple of years back. And just within the last year, actually going back about 5 months ago now, we released a product called Amazon Lex. So Amazon Lex is one of the components that makes up Alexa under the hood. It's responsible for speech recognition and then also for natural language technology. And so with Lex, and we'll show this working here, we could build conversational bots that take some level of us not needing to build exact programmatic interfaces, because it's going to help us understand some of the, we call intents and intentions around what we want to do with our app. And so Lex is something you can go and use today, fully managed service for you. You don't have to run anything, doesn't require any infrastructure on your side. So what are the components of Lex? So with Lex, there's a couple of different kind of key terms that we need to know. We have an intent, which is kind of the action that we want to take. Book a hotel, find me a flight, order me a pizza, launch this instance, deploy the code. Right? That is an intent. You can think of it as an action that you want to execute upon. From there, then we have utterances. Utterances are the things that are used typically to key off an intent or to help fill in information about the intent. Then we have slots. This is kind of further information. So we say, I want to launch an instance. It comes back and says, what kind of instance? And you say, I want to launch a large instance. Or I'd like to order a pizza. What kind of pizza would you like to order? A large pizza. Would you like any toppings? Pepperoni. So those various options are what are considered slots. And then lastly, there's fulfillment of this bot action. So this is after we've given our bot all the information that it needs to do what it needs to do, the bot then is going to do that work and execute that upon us. And this is typically where your business logic lives and where it's interfacing with other systems on your side and so forth. And so we see this here as an example in a mobile application using Lex. So let's break down a little further what is actually happening here behind the scenes. So Lex supports both text and voice-based input, so you can build into your application voice capture and pass it in. Or you could just have it be a text-based bot, maybe, and I'll show an example of this in Slack here in a little bit. So Lex is going to take that audio or that text. It's then going to break it down using the speech recognition technology that we have into the key phrases or key words that are part of the input that I send into it. From here, then, it's going to use the natural language processing technology that we have at Amazon, which again is the same stuff used behind Alexa behind the scenes, to figure out what the intent is of what we're trying to do. From here, then, it's going to look at the intent and understand, okay, what slots of information do I have to fill in about this intention that I'm trying to act upon? And so we see here that we're trying to book a hotel. So we said, I'd like to book a hotel. It's going to come back and ask us some information about what city, what check-in, what check-out. And we have the ability to do things such as validate this information, provide different options as part of this. So we can call out to things like Lambda, which we'll talk a little bit more about later. And then at some point, we've answered all the questions that our bot has, and then it can go ahead and fulfill this for us. So again, assuming that we're maybe someone like Expedia or Kayak, this could be something that could exist on our website, then we can go down and actually execute on this intention that I have as a customer or as a user of this bot. Poly, which I'm not talking about much at all today, is another one of the sibling services to Lex. And Amazon Poly is the voice technology that exists in Alexa and allows it to speak outward text that you send into it. And so you could then have your chatbot, if it was a verbal chatbot or an Amazon Alexa skill, speak back out the text that's been sent into it. So breaking this down again, utterances, these are the things that key off our intentions. So these are things, again, like I'd like to book a hotel. I want to make a hotel reservation. Can you help me book my hotel? And I want to book a hotel in New York City. Right, these are the actions I want it to take. Slots, then again, are the information about the intention, basically what is needed for my intention to be fulfilled. And so we see some examples here of a destination, a check-in, a check-out. Those have various types, and then they have various values that could be considered acceptable for them. And we can have our bot ask information about these slots, right? So we want it to understand, okay, if I have these slots that exist, I want to reach out and ask for this information in some way. And so we can make it, as we'll see here in a little bit, ask these questions of us. So on the fulfillment side, basically the execution of our bot action, today we support Lambda and then going back to the client with the information. So you could potentially have Lex standalone inside of your application, go back to your application with the information for fulfillment, and then have another part of your process fulfill it. Or you could integrate with Lambda for that fulfillment. And now I'm going to do a little demo. Okay. Cool. All right. So this is the Lex interface. I already have a couple of bots that I have created. Can folks in the back and to the side see the text? Is it large enough? You want to make it bigger? A little bigger? Okay, thanks. It gets a little difficult to see when I make it too big. Cool. So let's go ahead and take a look at an existing bot that I have. And I made this bot earlier today as I was trying to hack together something a little bit for this demo. This is called Jack's Bar and Grill. Jack happens to be the name of my 8-month-old son. And so what we want to have here is a bot that I could use to order food. And so what I've done here is I have a single intent, which is order burger. I then have a number of slot types. So these are potential capabilities about, oops, that one's not supposed to be there, about my burger that I might be interested in. Typically don't have flour types on a burger. So what I can see here is that I've created a couple of sample utterances, right? So these are the phrases that my bot is going to be looking for to trigger the intent that it's then going to gather slot information on that it might eventually fulfill. And so I've said things like, I would like to order, or I'd like to order a burger. I want a burger. Can I have a hamburger? I'd like a hamburger. And I could do a number of these to help kind of inform Lex of what I'm looking for, but I don't have to meet every single phrase that's out there. I then have the ability to invoke Lambda, which we'll skip over for now. Then I have the slots. So the slots, again, are the information that I need to complete this intention, to fulfill it. So in this case, I have 2 capabilities or qualities that I care about for my burger, meat and then cheese. And then these are broken up by various slot types. So now we have a bunch of built-in slot types for you. And so these are pre-existing types that exist that will be validated based upon basically a dictionary of type values that we have here at Amazon. And you can read all about what is inside of this online. And then, oops, at the end here, and it's a little hard to see, sorry, 1 second here, is the prompt for this. So this is an example prompt of what I would like to have asked when we come down to this, this slot fulfillment. So we see here, what type of burger patty would you like? I could have many different types of examples of prompts for this. And then what I have down below here is corresponding utterances. Again, these are examples of what is possible here. Sorry for the flashing. So again, I've given it some ideas of what it should be looking for. And what's going to happen is that Lex's natural language processing is going to take care of the rest. So understand some of these patterns, and then it gives me options to do more of that. One of the other things that we support in Lex is the ability to create what's called a card. So certain chatbot programs like Facebook Messenger support the ability for you to put an interactive kind of user interface inside of a chat conversation where you could just have either text fields or boxes filled in for them. In this case, I'm not going to show that. Let's go and add another thing that I care about. And actually, let me go and remove this one. Sorry. We'll keep it in here, it's fine. Whatever. So let's add a different slot. So let's add a slot type called bacon. So I've added a slot type called bacon. I'm now going to say the different bacon types that I could have on my burger. So we'll do normal bacon. And then we'll do more bacon. All the types of bacon there are. Cool. Let's go back to my burger here. And so now I can go and add another slot to this. So in this case, I'm going to add bacon as an option, slot type bacon, and it's going to say, what kind of bacon do you want? We'll add this in here. And now what we're going to do is just go and add the corresponding utterance. So type of bacon is, I would like bacon. So one of the things that we can do in these utterances is that we have certain replacement variables that we could put in here. So we could put in, for the slot types, the values that we've pre-programmed into it. So basically saying those are the right types of, in this case, bacon that I care about. Or we could just make these kind of straightforward phrases. So gives you that aspect of dynamicness if that's what we're looking for here. Cool. And actually one thing, okay. And then we save this intent. And before I build it, let me show you one other thing about this. So down below here, there is a concept of a confirmation prompt. This is after all of the slots have been filled. So basically, I've asked all the other questions that I want to ask. This is my ability to have it confirm that this is what I want it to do. So this can be a useful kind of checkpoint of, hey, do you really want to order that super extra large pizza with everything on it, yes or no? And then based on this, you can think of it as almost kind of a gate between the fulfillment happening or it not happening. And so in this case, I do have a fulfillment or confirmation question. So we'll save this, and we're going to build it. Cool. So while I'm waiting for that to finish, let me go, or I'll wait for this to complete here. So it takes a moment or two. And so what's happening is it's building out the logic for my bot, and then it's going to make it available. And then I can actually, right here in the browser, that blue window, which will open up here in a second, test my bot out. Cool. Awesome. So I have my test bot window down here. So this is going to allow me to converse with my bot. So say I like a burger. Comes back and says, what type of burger patty would I like? I'll say beef. And I got an error because I forgot to turn off my broken initialization. 1 second. This is what happens with live demos. Cool. We're going to go back to another example that I have that's already up and working. This is why you always have cooking show style, one working demo and one broken demo. So we have actually a sample that you can go through on the Lex website, really super easy, quick to set up. I'll actually show you what it looks like to go through it. So you can say create new bot, and then we have 3 pre-existing examples that you could find. So in this case, I'm going to go back to one of them, which is for a flower ordering site. And so what this has here is it allows me to order flowers. There's then 3 different slots for the flowers. I'm just going to make this a little smaller. My apologies for folks in the back. 3 different slots that I have. I have flower type, pickup date, and then pickup time. And then what we have here from those slots is, in terms of the types, is there is one predefined type, or one custom type called flower types, and then 2 Amazon types, so Amazon date and Amazon time. Now if I go down to my test bot here and say, I'd like to order flowers. What kind of flowers would you like to order? Say roses. What day do you want them to be picked up? I could say tomorrow. And so it goes and figures out that tomorrow is the 2nd. At what time? And I can say 4 o'clock. 4 p.m. Cool. And so what we see here is that it actually didn't understand what 4 o'clock meant in the way that I typed it. So typing 4 p.m. worked out just fine for it. And then it comes back with a confirmation prompt. Do I want to place this order to have my flowers delivered tomorrow at 4 p.m.? And I can say yes. And it's going to come back and say, great, we're going to place that order for you. Now, what could be happening in the scenes here is all sorts of validation around whether or not things that I entered were right. And we'll come back to see that validation a little later today. So go back to my slides. Cool. So really easy to get started. I didn't start from scratch on this one, but very easy to create a bot, create the utterances that you want, create the slots that you want, define the slot types, go through and figure out the utterances for your slots and so forth, right through that web interface. From there, what you can then do is go through a very traditional dev workflow for these bots. Right? So we want you to be able to treat these just like you would any other application that you have. So you saw me save it, you saw me build it, and then I was testing it there in the web browser, but I also would have the option to publish it. Or as you saw, I built it, I tested it, and in the case of my burger order, I had to test it a couple different times. So with Lex, we support things like versioning and aliases. So you can have prod staging dev for aliases, and then every time that you make a change and save it, it creates a new version for you. So it's not something you have to think about yourself. So with Lex, we have integration today with 3 different bot services, so Facebook Messenger, Twilio with SMS, and then Slack. And so we can bring this bot experience right into those platforms without you having to write any other interface code yourself. And so I'll show you this in Slack real quick. That's not me. Okay. I was like, did I do something wrong? Cool. So I have a Slack channel, or I have a couple different Slack channels. And so what I've done here is I've already integrated my burger ordering bot into this. So I'll show you here what this looks like. So if we go into the API for Slack, so how many of you have ever built a Slack bot before? A couple people, awesome. So it's actually really straightforward for me to get going with this inside of Lex. So I'll show you here real quick. If I go to Lex and click on channels, get rid of this. Sorry, what I already have is, so I already have a predefined app that's down below here. Unfortunately, it doesn't show you all of the other information already because the tokens and stuff, it takes and encrypts and hides from you. But if I go back to Slack API, you can see that if we click through all of this, and it's a little lengthy to get everything set up, basic information about this, credentials, I'll have to kill all those later. Basically what it ends up doing is Slack goes and looks at 2 of the URLs that are created by Lex. There's a request URL and an OAuth URL. And so in this case, my bot is unauthenticated from within inside of Slack, so it's automatically authenticated, versus if I had a bot that I was running in another application and maybe I wanted to do something like federated login via, say, Facebook credentials to it. So it is something that you can do with Lex. And so my bot is sitting here in Slack, and so I can pretty much just straightforward say, I'd like to order burger. And we'll say turkey. We'll say Swiss. Yes. All right, so nothing too exciting here, right? But I'm conversing with this bot that's running out on Lambda. I'm sorry, it's running out on Lex and able to take in the prompts that I have and ask me the questions that it needs to fulfill its slots. Now, my demo in the browser was broken, as we saw that before. However, here in Slack, it's completely working. It's not because the change that I pushed magically is working, because it's probably not, because that's how the demo gods like things. But what's happening here is that my Slack bot is pointed to a certain alias, which is tied to a certain version of my bot. So even though I've gone and broken the most recent version of my bot, I have this versioned aliased version of it that's published to Slack that I don't have to worry about breaking. So again, separation between kind of production and development in this case. And so pretty straightforward to set this up. I won't go too in depth here on how permissions work in Slack, but there's different events that you can subscribe to. There's various different permissions that you can assign on top of that based on what you're looking to do. But again, my bot that I interface with in Slack, basically I fill out the form to get that bot from Lex integrated with Slack, and no other user interface work has to be done to make that happen. Cool. Awesome. And so one of the key things that we consider kind of a key tenet of serverless technologies at AWS is that monitoring and logging are built in by default. So these are not optional things in the modern world. And for me, as a former DevOps and operations person, where I spent a lot of my career tweaking and building out monitoring and logging systems, it's pretty awesome to have that built in. So I can actually go in and find out things like missed utterances. So am I not capturing all of the phrases that people would want to put into my bot? Request latencies, how long it's taking to serve that, and then traffic by channel. So in this case, Slack was a channel, and I could have multiple Slack rooms that could exist as part of this. And so Lex is a pretty complicated piece of technology. There's a number of different components that make it up and then it interfaces with. So obviously we've got an API and an SDK that you could just write your own raw applications for, interfacing with it. And then we've got the pre-built Facebook, Slack, and Twilio integration. It also integrates with a number of other AWS services, such as Cognito and CloudShell and CloudWatch. But what I want to talk about here last is Lambda. So Lambda, I mentioned, is kind of the key in our world for serverless at AWS. And we consider a serverless application to be one basically built around it, where you have an event source, you then have your function or functions, and then it completes with sort of an action based on it talking to a data source or another API or something that it might interface with. In the case of today's example, my event source is going to be Lex, in this case calling Lambda, and then the services that I talk to maybe nothing or maybe something, depending on what it is that function is going to do. How many of you are familiar with AWS Lambda? How many of you use Lambda today? Oh, awesome, okay. I'll go through this as quick as I can for those who are not familiar with Lambda, because there were some people in this room who are not. So Lambda is a compute service here at AWS. It's a completely managed service for you, where, again, the idea behind a function as a service platform is to decompose your application into the most kind of bare primitive functions that you can. In the case of Lambda, we have a number of different languages that we support, so Node.js, Python, Java, and then C#, a couple different versions. So we just launched Python 3 a week or two ago, Node.js 6.10 about 3 weeks before that. With Lambda, the only knob that you really tweak is the amount of memory that you want your function to use. So today, we support from 128 megs up to 1.5 gigs. There's kind of a correlation between the amount of CPU power that you get with memory. So if you have a very compute-intensive task, giving it more memory is the best thing to do. And then a timeout. And basically, with Lambda, you pay in hundreds of milliseconds of execution time. And so when an event is triggered, such as Lambda, or such as Lex calling Lambda, we fire up a resource to run your code, we execute your code, and then we basically stop billing you after it's done with executing. In terms of authoring functions, so we have a web console, which I'll show here in a moment. You can use any IDE, and we've got a number of development tools and things that interface with it. Again, monitoring and logging are built in. I'll skip over the rest here. So one thing that people don't know is that we actually have a little over 20 different event trigger types for Lambda today. So Lex is just one of them, but a lot of our infrastructure tools, a lot of our database services can all invoke Lambda. And so there's a lot of really interesting things that you can do with it. And there's kind of 3 different models for how those event triggers can work. There's a synchronous model, basically where it is going to trigger the Lambda function and not wait around for anything to happen. There's more of a synchronous push model, such as Lex, where it's going to look for a return from Lambda to come back, as opposed to just kind of firing for getting it. And then there's the stream pull model, which exists with Dynamo and Kinesis, by which you can actually stream requests through Lambda, and it will process them and then keep on processing more over time. And so depending on your use case and what you want to do with Lambda, these 3 different models exist. Again, we're going to be focusing on the middle one here, which is more of a synchronous model, given that our Lex conversation bot isn't going to want to go back and pull for some information. It's going to want to answer right away from Lambda. And so combining Lambda and Lex is actually really, really powerful for chatbots, and I'll show this here working here in a moment. Both kind of meet the criteria that we have for serverless applications. They scale on demand. You never have to think about capacity planning. You never have to pay for idle, and they have fault tolerance and high availability built into them. Lex is a completely managed service. Lambda provides complete abstraction kind of below your application code. And so if you think about something that can provide a lot of value to your customers, that has this logic built in, that can help you, not have to have a lot of higher operational burden, this is a lot better than just writing it yourself and running it on traditional compute resources. At least that's what we feel. Other things is that both of these services support versioning, aliases, I mentioned before, monitoring and logging, authentication, authorization, so you can actually build a very secure chatbot given whatever else it might need to do inside of your infrastructure. So let me show you this working, actually. Yeah. Where did my window go? Yes, cool. So this is what broke in my, my other example here. So let me go back to the editor and see if what I was doing is now working. And actually, I'll explain why it broke. Cool. OK, so in that case, it didn't break, which is exactly what I wanted it to do. So in this case, I'm talking to my bot, and what I've done is actually turned off the Lambda checker for this capability. So what I had turned off before was Lambda initialization and validation. So there's one thing about this that's kind of interesting. So if I were to go right now and look at, for all of the slot types that I have filled out, for example, if I go and look at meat type, I have vegetable, beef, turkey, and veggie. If I go back to my chatbot and say, I'd like a burger, and it says, what type of burger would I like? And I say, I would like a shoe burger. It's going to say, great, what kind of cheese would you like on your shoe burger? Right? So it's not actually doing any validation of the values that I'm putting into this function. And so I could say, well, I'd like some tree cheese on my shoe burger. And it's like, what kind of bacon do you want? And I say, whale bacon. I don't know if that's actually probably a horrible thing. So it's offered me up my shoe burger with tree cheese on it. Great, not what I want, not anything that I would like to have happen. I'm going to come back over here to this other example that I have from the example that you yourself can run, which is this flower store example. And so I can say, I'd like some flowers. What type of flowers would I like to order? Shoe flowers. We do not happen to have shoe flowers, but there are other options for flowers that I could choose. So it recommends roses. Roses are lovely. Why not? Great. When do I want the roses to be picked up? Mars, nope, doesn't like that, right? Yesterday tells me I could pick them up from tomorrow onwards. Okay, so say tomorrow. When would I like to pick them up? Never. Doesn't like that either, right? So let's see if I spell o'clock right, if it will like o'clock. Nope, okay, cool. So what we're seeing here is that basically at some point it got annoyed with me typing random stuff in it, and it just said, go away. So that is one of the capabilities that you have in Lex, is to basically build out the, what we call a hang-up phrase that ends the chat. But what was happening here is the values that I was passing in to my chatbot slot utterances were being passed back to a Lambda function. And so that Lambda function, I'm going to show you here, which we also have as part of this demo, so you can demo the Lambda function independently, is actually going and it's looking to find a number of different things. So one of the things that it's doing is it's validating my types. So I can see here that there's only 3, and hopefully folks can read that more in the back, a little bit bigger here. There's 3 flower types that it likes. So it likes lilies, roses, and tulips. And I could do something, for example, like have this plugged into a DynamoDB table full of all of the types of inventory of flowers that I do have. So I could basically say, hey, you know what? This is all that I have in inventory. So the options here are kind of open. And so this is basically going through validating the various options that I have, making sure that the date that I entered is a date that is logical. And that is the difference between this working example and my broken burger example. And now plugging this in is really straightforward. So I have my Lambda function. For those of you who are not familiar with Lambda functions, they get, let me make this a little bigger here. Actually, we can test it right here in the browser. We can see a bunch of information about how it is set up, the amount of memory that it's using, the duration of time. I can go over to the monitoring tab here, and I can see various metrics from this individual Lambda function. So I can see its executions, you can see the duration of time that it took. In this case, this is a pretty short duration function, 30 milliseconds here, and then one of these which was just 1 millisecond. I could also go then and view logs and CloudWatch for this. and dive into kind of the exact output from this function. So all of this built into my Lambda function, not anything that I have to set up myself. Let me go back to Amazon Lex over here for this flower ordering bot that I have. And same thing, I can come here and look at the monitoring for this. You can see all the various metrics that are part of this. You can see utterance of tables. Refresh. Oh, because I haven't published it yet, that's right. Sorry, in test mode, it's not capturing everything, but I see here the metrics that exist. Let me see if I come here. Detect it. I had to figure out what I did wrong there. Anyway, I can see the various monitoring here of things that have worked and then not worked for me. So we saw there Lambda being triggered by Lex and then providing it validation for the things that I'm entering. So real quick here about Lambda, two real quick things I want to talk about. So one is that back at the end of 2016, we released a tool called SAM. SAM stands for Serverless Application Models. It's basically a framework and a tool for deploying Lambda-based applications. And it makes it really, really easy to deploy Lambda functions without having to do a lot of really complicated scripting or tooling around it. So this is an example of a SAM template. Basically, this is an abstraction on top of another tool that we have called CloudFormation. And so the kind of 20 or so lines that we have right here would create for me a Lambda function, an API gateway, and then a DynamoDB table. And I have one of these I'll show you for the current broken example of my burger shop. But really, again, simplifies what it is that I want to do with deploying this. The other is that 2 weeks ago at our summit in San Francisco, we released a tool called CodeStar. CodeStar is a development web interface for teams or individuals to basically create predefined application environments with things like a code repo, a delivery pipeline, a build service, and then a deploy mechanism put in there for you. It actually creates teams via permissioning, so you can add people to your project, and then pulls in graphs and other interesting things about that. I'll show you real quick what this looks like. So for my currently broken example, the SAM code that's relevant in this case for deploying this function is just these kind of 8 lines right here. And in this, I'm defining the language that I'm using, the handler to call, and the permissions that this Lambda function needs. So super straightforward. Oops. If I go back up here to the console, I can then come in here and see the CodeStar interface for my burger function, which is, again, currently not in any 100% working state. And what I see here is a commit history. I see my pipeline history. I see invocation information via CloudWatch. And so as a developer or development team, I could basically just sit and watch this dashboard and have visibility into what's going on with my application. And it's really easy for me to go and create more example kind of environments here and create a new project. We've got a number of projects that are predefined. And again, it's going to give me a code repository, a pipeline, a build, and a deploy capability for this. So in this case, when we talk about build, this could be everything from code compilation to unit testing to pulling in things like NPM modules or pip packages. All that kind of stuff could happen as part of that. Almost out of time. Cool. So in closing, we've seen kind of a bunch of different things put together here, right? So first we saw Lex, really straightforward and easy to create a chatbot of your own for whatever it is that you're looking to do with a chatbot. Natural language processing built into it, so I didn't have to put in exact utterances every time. I didn't have to fill in slots exactly right every time. And then what I was able to do was add Lambda for some validation of that information. So again, right out of the gate, it's not going to necessarily know that I don't have a, in this case, a shoe flower, I believe, is what I had entered at one point. And so that logic built in with Lambda, really straightforward to script up, really easy to basically do a function that just validates that information or acts as the fulfillment. So again, if I was actually ordering those flowers, I could use a Lambda function to place that order for me. We actually have a chatbot competition going on right now through July 18th. If you combine Lex and Lambda, you have the ability to win free tickets to reInvent, which is our yearly user conference, or cash prizes, which is pretty cool. We also, about like 2 months ago, released a serverless landing page, talks about Lambda, talks about Lex, talks about API Gateway, and all the kind of the related things that are there. Again, my name is Chris Munns. I'm a senior developer advocate for serverless technologies at AWS. I'm going to take questions outside because I realize I'm almost at the end of my time here. So I'll stick around out here in the hallway and happy to try to answer any questions that I can. Or you could find me at my last name, Munns, at Amazon.com, or at Chris Munns on Twitter. Like I said, questions in the back. And then please rate this session again. This is my first time at a GOTO conference. Looking for kind of where the bar should be set for this type of a conference, so what you, the audience, are looking for. Hopefully I can come back and speak at another GOTO conference someday, but really would love to know what I can do to make this conversation better. So thank you again. Have a great rest of your week here.